Okay, so the first thing that we're going to start with is by explaining what exactly is MATLAB. MATLAB is basically a programming language. Some of you here are computer science majors, so you'll go on to learn more advanced programming language like C++, Java, and so on. But for other engineering majors that you do not need all that detailed, complex programming, there has been a structure that was created, and it's called MATLAB, and you can actually perform a lot of operations, a lot of simulations, using some straightforward, so to speak, line-by-line operations. Okay. Again, it is a new software, so it might not be as intuitive for some people. If you have any programming language background, it will be kind of straightforward. There are some terminology that's different between MATLAB and other programming languages. So just kind of be aware of that. But we're just going to take it step by step and build it from there. So if you open up MATLAB, you'll see that we have a couple of window interfaces. The main one over here, this is called the command window. This is where we're going to type our code, and we're going to get the results. We're going to do a couple of examples in a second. The workspace over here is where the value of the variable is saved. So we have variables saved here, and those variables could be single value variables, or they could be a matrix, and they could all be saved over here. And you're going to see that as we actually run the programs, we're going to get more and more variables created over here. Over here is the command history. Yours is probably empty because you just opened the program. I've been using the program for a while, so that's why it has a history of all the commands that I've already used, and that's what you see over here. Okay, so let's start by doing a simple operation, and that simple operation is simply like a calculator. Okay, we're going to do a simple addition, simple subtraction, multiplication, and division, just to prove that MATLAB actually does all these simple operations. So if we come over here, and for clarity purposes, if in the back of the room you want to see it better, I will be using the magnifying glass. It's not what I want. There we go. Alright, so on the top you should be able to see a 200% zoom. Okay. So when I write that code, in the back you should be able to see it better. Some of that code will be in green in a second, so it will be more difficult to read. Okay, so let's start by something simple. For example, 8 plus 5. So if we just type 8 plus 5, and then in order to run the operation, we have to click enter. And you're going to see that if I type 8 plus 5, I'm going to get answer equals 13. So ANS is a random variable assigned, and I can see that ANS has been added to the workspace over here, and the value of that ANS is 13. Now, you have to remember that ANS is actually not the best option. Every time you want to use MATLAB, we want to assign specific variable for each value. Okay, so if I just type 8 plus 5, I'm not assigning x equals 8, y equals 5. I'm just saying automatically 8 plus 5. That's why I'm getting ANS. Now, what happens if I type 3 multiplied by 2, and I also hit enter? You'll see that I get the same variable, ANS equals 6, and the value of that variable that was 13 a second ago has been overridden by the new value of that variable, and now it's 6. So you'll see why it's actually not a good idea. Trying to figure out how to resize this so it's slightly bigger. There we go. So you'll see why it's not a good idea to actually just type in these operations without specifying values to variables. A more accurate way of actually doing these calculations is by assigning those variables. So what I can do is I can say x equals 6. Basically what I'm doing is I'm specifying the value of 6 for the variable x. So if I say x equals 6 and I hit enter, you'll see that x equals 6 is actually run as a code, and the value of x as 6 is actually saved in my workspace. Okay? Please remember that MATLAB is case sensitive. For example, x equals 6 is different than capital or uppercase X equals 4. So if I say x equals 6 and x equals 4, although they're kind of the same letter, but since they're uppercase and lowercase, over here in my workspace they're actually saved as completely different variables. Okay? Now, okay, we can keep going through this, but you'll see that what happens here, as I keep typing these commands, you know, I say x equals 4, and it kind of like tells me again x equals 4 because it's trying to run that code. What I can do is, in order to prevent this from showing, the x equals 4, every time I run a command with a given value, so I know that x is 7, I know that y is 3, I know these values, what I can do is I can say y equals 3, and I can follow it by a semicolon. What a semicolon will do is it will prevent the code from actually being a display run, but it will run in the background and it will be saved to my workspace. If I say y equals 3 and I hit enter, you'll see that I get to my second line of code. So it will not show me y equals 3, but y has been saved in my workspace. Is that clear? Okay, so we learned semicolon. Now you'll see here that as I keep going, this is kind of compiling more and more, and this is really not the best operation for me, because if I close this, I have to come back and I have to type all these commands again. So it's really not the best way. So in a second, we're going to be talking about mfiles. But before we get there, let me show you a couple more things. If you use the up and down arrows, so if you use the up arrow, you'll see that you'll actually go back through your command history. Yours will probably not be as long as mine, but you can actually go up and down and you can go to that command history. Okay? So in addition to that, what do we have? Let's say now I'm going to run an operation. I'm going to say z equals x divided by y. Okay, so I'm going to say x divided by y. I'm going to hit enter. So basically what I'm saying, x is 6 divided by 3, I'm getting z equals 2. Notice that because I want to actually run the operation over here, I did not type a semicolon following it because I actually want to see that result. Okay? Alright, now you keep doing this and you're going to see that you're going to run out of letters as variables. Well, you can actually use anything as a variable. You can, for example, say age underscore John. That means that's the age of John. So MATLAB, you cannot put spaces in a variable, so usually we try to replace that space with an underscore. So if I say age underscore John equals 28, age underscore John is basically going to be its own variable name. Okay, so I can really name my variables whatever I want as long as I'm clear in my commenting, which we're going to cover also in a second. Okay? So let's keep going from here. We keep writing these commands, and we get, after a point, we're going to have 10,000 lines of code, and we're going to forget exactly what variables we use and what variables we didn't use. And this list is going to be so long that you can't really tell if you already used the variable w or you haven't. So how do I check for that really fast? Let's say I'm checking if I use the variable x. All I have to do is just type the variable x and I hit enter. And if x actually returns a value for me, that means x is in use and the value has been assigned to x. Okay? If I try to find w and I go ahead and type w and I hit enter, you'll see that it will come back with an error message saying undefined function or variable w. Basically, this should be an indication to me that I have not used the variable w. Okay? Now, how do I change the value of x? For example, in this workspace, I know that the value of x has been stored as 6. How do I change that value? Well, that's very easy. All I have to do is just type x equals whatever the new value is. If I type 8 and I run the command again, the previous value of x has been overridden with a new value of x. So MATLAB will just override the values of the same variables. That's why you want to make sure that you're using different variables if they're really different variables. Clear? Okay. So we have all this stuff here. Now this is going to become too much. Now, how do I erase this whiteboard? How do I kind of like remove all this stuff and start from a clean slate? In order to do that, you can type CLC. So CLC will basically clear your whiteboard. And if I type that, you'll see that my entire space here got cleaned out. Okay? But my workspace is not cleaned out. You'll see that the variables are still saved here. That means I did not delete my memory. I just erased the whiteboard. Okay? Now, how do I actually remove that memory? If I want to completely erase that memory, instead of CLC, I'm going to use clear. So when I type clear and I hit enter, you'll see that that workspace has been cleaned up. Okay? Any questions so far? Alright, let's go from here. So this is actually not the best way to write code, because every time I launch this, I have to either rewrite the code. Notice that if I change the value of x, I have to write all these lines again. So it's not the best way to run the code. What we're going to be using is something called Mfile. And how do we get to that? We're going to go to File. Okay. new, okay, and script. So file, new, script. Okay? So you'll see that for yours probably it will look something like this. It will be a pop-up window. It's best if you actually dock it, and the way we're going to do that is we're going to go to the Desktop tab here on the top, and we're going to click on Dock Editor. Okay? Does everyone have this? So if I click on Dock Editor, now what's going to happen is we're going to write our code over here. Okay, and we're going to write, and where the results are going to be displayed over here. So the good thing is everything will be saved here like a text file, and we can run the entire code at once, and we can get the results over here. Is that clear? So what do we want to do? Every time you start a code, you want to start that code on a clean slate. So my recommendation to you is you always start with clear CLC. So what that will do is it will erase the memory, and it will erase the whiteboard, so you can start fresh for every problem that you're going to run. For your homework assignment, you need to create one of these Mfiles for each problem. So do not do the entire assignment under one Mfile. You need to create a separate one for each assignment, for each problem. Okay, so before I go any further, the problem that a lot of students face is naming these files. So I'm going to go to File, Save As. Okay, and you can choose your flash drive, your desktop, wherever you want to save this. Now here's the deal. In the actual file name, you cannot use the word MATLAB. You cannot use the word problem. So there are specific words that have been taken up by MATLAB. So we're going to try to avoid those words. And my recommendation to you is, in your homework assignment, you're going to see that you have something called Activity 1.1, Activity 1.2, Activity 1.3, and so on. So how do we save that as an assignment? All we have to do is we can type activity, and again, remember, no space, underscore 1, underscore 1. So that's activity 1.1, 1.1. And you do the same thing with 1.2, 1.3, 1.4, and so on. Is that clear? So we're going to go ahead and hit save. So now this is saved, and I can see the title over here where it says MATLAB / and then that should be the file name .m, because we just created an M file. Okay? So let's keep rolling from here. Okay, so we're going to need to start our code with some sort of introduction. You know, who's creating this code? What does this code do? And so on. In order to write a comment that does not run as part of the code, I can use the %sign. Okay, so the %sign starts a comment, and I can say created by, and you can type your name. Okay, I can put another comment, for example, created on, and you can put the date here, and you can basically specify what problem is this. So this is activity 1.1. Okay, so you can basically specify all these comments, and comments are not only used to do introductions, they're actually used to explain your code. So you can't expect someone to look at your code and understand what you're doing. Usually you want to follow each line of code with some sort of instructions or comments of what you're trying to do with that line. Does that make sense? So usually what I try to do is I then put a % and just put like an underline, so I separate the introduction from the actual code that needs to follow. Yes?
Do they have comment blocks or just single line?
Single line, yeah. Are we good? Okay, so let's start with this. Let's say we're going to do something very basic, so we're going to start with x equals 4. And again, remember, we need to put a semicolon because we already know the variable of x, the value of x, and we can say that we can put a comment here. X is the age of the child. Okay? And then we can say y equals 2.2. And I can put a comment here that says y is the conversion variable of height of child. Okay, I'm just making this up. This is not biologically accurate in any way or form. Okay? You can do problems of converting kilograms to pounds, whatever it is. I mean, I'm just getting you introduced to the concepts for now. Okay? And let's say h, and remember, you can type h, you can type height, you can the variable name doesn't really matter. I can say h equals y multiplied by x. Okay? And I can say this is, I can put a comment, this is the height in inches of the child. It's going to be a very short child. Okay? Is that clear? Any questions? Alright, so now all I have to do is, do you see this play option over here? You can either click on play or you can click on F5. And when you click on play, the code would run, and you'll see that, notice here on the results on the command window on the bottom, I actually forgot to put a semicolon next to y. So that's okay. I realize that I made that mistake, so I need to fix it. But I get h equals 8.8. So the height of the child at 4 years old is 8 inches. Okay? But notice everything is saved over here. Now let's say I made a mistake. It's actually not 2.2. It is 10.2. So all I have to do is just come back and change that very easily. I can put a semicolon here. So any changes that I do to the code, and I can just hit play one more time, and the code would run again, and all these changes would have been updated. So instead of writing the code every single time, it's just saved as a text file, and I can run the entire thing again. Now, one of the things that you have to understand is MATLAB runs line by line. For example, if I have an error here on line 6, it will actually break on line 6. It will give me an error message, and it will not continue on to line 7, 8, and 9. Okay, so let's try to simulate a mistake here. Let's say instead of 4, I made a mistake and I typed like 4 plus. Okay, a typo. So I had that issue. But I did not notice it because I have 10,000 lines of code and so on. So now when I go ahead and run it, it's going to give me an error message that says there's a problem here on line 7. Okay, do you see that? So it really helps you understand where's the problem occurring. So you just go back to line 7 and be like, oh, okay, I see it. I'm just going to fix that. Try to run it again, and there we go. Is that clear? Any questions? Are we good? Okay, let's try something more interesting now. Let's do something in terms of time and position of a ball that's being thrown off like an edge of a, the side of a building. Okay, so how do we do that? Let's say we're actually timing. So we have time, but time now is not a specific value. Time is changing. It starts at 0, and we're actually collecting data points every 0.2 seconds. So what do? The standard is, so don't do this yet, I'm just typing the standard so you guys can see it. The standard is you say t equals square brackets, you type your min value, followed by colon, followed by the increment, followed by the max value. Okay, so that's the standard that we need to follow. So what's the minimum here? The minimum is 0, and I need to collect a point every 0.2 seconds, so the increment is 0.2, and the maximum is 5. So basically I'm going from 0 to 5 seconds at an increment of 0.2. So that's a lot of values for t. So you want to make sure that you don't want to see that long array of numbers. You always follow that by a semicolon. Okay? Semicolon just prevents it from being displayed in the command window, but it will actually run it in the background and it will save it to the workspace. Okay? So now if you go ahead and run this, you'll see that over here it tells you t is 1 by 26. That means there are 26 elements inside that t. If you want to see what t is, just remove that semicolon and try to run it again, and you can see it's 0, 0.2, 0.4, 0.6, and you can see all these values until it hits 5. Is that clear? Okay, we're going to put a semicolon because we don't want to see it. What? F5 or the play? The play button over here. Yes. Are you getting an error message type char? So if you get an error message, that says undefined function or variable of type char, that means your file name is wrong. That means you use space in your file name. You use a word that MATLAB already uses. So for example, if you use sample, that's already used by MATLAB. Okay, if you use problem, that's already used by MATLAB. So that's why I'm telling you, just follow the standard that I gave you, which is activity underscore 1 underscore whatever the problem number is. Okay? Alright, so let's go from here. We have t as 0, 0.2 till 5. Okay? And now let's say we're going to go ahead and plot the position. So the position is y, or you can type height, or whatever you want. So height equals, I'm going to type 0.5 multiplied by g multiplied by t squared. Now t is an array. So what I'm going to show you today is something that we're going to elaborate on in the next lecture. I just want you to trust me on this for now. Since t is an array, I want to square every single value. So basically what I'm doing is half at squared. So if I do 1/2 gt squared. Now how do I show the squared? I need to put a dot caret 2. What a dot does is it makes sure that every single value of t is squared. Because I have to run this 26 times, correct? Okay, so I'm going to take it from here, plus v underscore 0 multiplied by t. Okay, so if you've had Physics 111 or 121 or Introductory Physics, you know that the position of a projectile is 1/2 at squared plus v naught t plus y naught. So I'm just going to go with that for now. Is that clear? So can we run this code? Do you think it will work? What do you think the problem will be? G is not defined and v naught is not defined. So before I get to line 8 over here, I have to specify that g is negative 9.8. So I'm going to be throwing it. So it's negative gravity. Okay, and I'm going to put a semicolon next to that because I already know the value. And v naught, remember, use a 0, not an O. You can use an O as long as you're consistent. And I'm going to say that's 0. And I'm also going to use a semicolon next to that. Now, do you want to put a semicolon next to height? Well, do you really want to see all these numbers, or maybe do you want to maybe plot it so you can see it better? Because all these numbers don't really make any sense for you. So maybe we do want to put a semicolon here there. Okay? So you want to get those semicolons there if you have big arrays, because you don't want to see all those numbers being shown on the screen. Okay? Are we good? So let's go ahead and run this to make sure that it runs so far. So we'll notice from the workspace we have G specified, height specified, T specified, and V not specified. Now I'm going to show you a couple of things here on the side. Let's say you want to figure out how many elements, how many numbers are in the array of height. So one way of doing it is I can look over here and I can say, okay, there are 26 elements. But if I want to display that result, so if I want to say, you know, elements underscore height equals, I can use the command called length, and I can type length of the height. So basically what I'm doing is I'm trying to extract how many elements are in the height array. And I don't want to put a semicolon there because I want to actually see that number. In addition to that, for example, let's say I want to pick, you know, the 10th one. Okay, so I know there are 26 there, but what's happening at the 10th increment? So if I want to pick the 10th, so let's say 10 of the height, and again, those are variable names, so you can call them whatever you want. I'm just naming something that kind of sounds reasonable. If I want the 10th element, basically what I need to type is height of 10. So height parentheses 10 will pick the 10th element of that height array. Is that clear? Okay, so this looks good. Now we're going to go ahead and click on play, and we're going to go ahead and run it. And we're going to see that the elements in the height, there are 26, which is just exactly what we thought before, and the 10 height is negative 15.87, and that's in meters, of course. Okay? By the way, I skipped the comments here, but I highly recommend that you actually put comments everywhere. So for example here, you definitely want to put a comment explaining what the units are. So G, it's negative 9.8. What is it in meters per second squared? Okay, so you definitely want to do that so you actually clarify what unit system you're using and so on. Okay, so I'm going to show you one thing. Let's say you keep using these variables and you want to figure out if you want to get a list of all the variables that you've used already. If you go over here on the bottom where it says command window and you type the command who, so WHO, and you actually run this, you will get a list of all the variables that you have used so far. Okay, is that clear? So who will allow you to see the list of all the variables, and we just learned a second ago how do we test for a specific variable if it's being used or not. Okay, so where do we go from here? Okay, let's say we want to plot this. We want to plot height versus time. So time needs to go on the x, and plot needs to go on the y. So I'm going to say, alright, I'm going to type plot t, comma, height. So I'm plotting time as x and height as y. So plot x comma y. And if you go ahead and run this, a window should pop up, and that should show you the displacement of that ball with respect to time. Is that clear? Now, what you'll notice is when you see this, is this a good chart? Is this something that you can attach to a report? Okay? Go ahead and attach this to a report and you'll get 0 credit. Okay? There's no title, there's no X label, and there's no Y label. How do you even know what I'm plotting here? Okay? So there's no way that this is actually a good plot, so I need to specify exactly what I'm plotting. So I can come over here and I'm going to run you through an error scenario. Okay, so listen up, this is going to give you an error. I'm going to run you through an error scenario. We're going to start by actually typing the title. So title, I'm going to use parentheses, double quotations, and I'm going to type the title of that chart. So this is going to be height versus time. I'm going to close the double quotations and then close the parentheses. You can even remove the parentheses for now until we finish that. So it turns purple like this. So title, height versus time. Okay, then I want to put in a label on the x-axis. So I'm going to say x label. I'm also going to use double quotations. I'm going to say time, and that's going to be in seconds. And I'm also going to do a y label, and that's going to be height in meters. So all this is script text. It means it's actual text. Okay? Are we there? So go ahead and run this code, and hopefully all of you should get an error. Okay? It freaked out and told you something went wrong at line 14. You're like, what did I do wrong? Okay? Well, I'm not in class, so let's see what can I do in order to get help from the MATLAB help option. So I can come over here to the command window. So I'm on the command window, and I can type help title. So I need help with titles. Okay, and I go ahead and hit enter. So when I type help title, I'm going to get a series of examples that show me how to use the function title, and I'll see that from here it's actually not a double quotation, it's a single quotation. So it's title, single quotation, and then the text that I need to type. So I come over here, I'm like, oh, got it. Alright, so I need to change this from a double quotation to a single quotation. I'm going to do that the same thing with the X label. I'm going to do the same thing with the Y label. Okay, is that clear? Okay, so now let's go ahead and run this, and you'll see that you're going to get a chart that actually has a title, it has a Y label and an X label, and since it's part of the code, I don't have to do this manually every time. It's already there in my chart. Okay, is that clear? Now, how do I copy this chart? I do not put it in full screen mode and take a screenshot of it. Okay, that's not the way we do things. The way you have to do it is you're going to go to Edit and then Copy Figure. So Edit, Copy Figure. If it didn't come up, that means it's already open from the bottom. Hover over MATLAB and you'll see that you already have the chart in there. Just click on it and it has been updated. Okay? After you get the question a couple of times, you can. Alright, are we good? Everyone there? Any questions on this? Does everyone know how to plot? Okay, basic plots. We haven't done anything fancy yet. Nothing fancy. Alright. Now, I just want you to look at the board for this. You don't have to follow along. But let's say I'm actually plotting also velocity. So velocity is equal to g multiplied by t plus v naught. Okay, so I'm also calculating velocity. So if I want to plot, this is like so wrong in so many ways, so do not like listen to what I'm going to say in terms of units for a second. I'm just showing you how to plot different things. But if you want to plot velocity and height on the same chart, okay, remember velocity is a different unit than height, so you know I'm not doing a physics disaster here. I know what I'm doing. I'm just showing you the possibilities. You can actually just do plot t comma height comma t comma velocity. Okay, and if I go ahead and run this, you'll see that you can actually get two charts over each other. One of them is blue and the other was green. Okay, now the question is, which one is which? Okay, especially if you plot like 15 of those over each other, which one is which? What you can do, of course, you know, you have to change the title and so on, but what you can do is you can use something called legend. Okay, and using that legend, you can specify which one is which. So we plotted the height first. So the first one will be height, okay, and the second one will be velocity, okay. Now something's going to happen, and that's for you to kind of take it off from there, but I'm just giving you the starter hint on this. Okay, so if I go ahead and run this, okay, you'll see that I have height and velocity. So I know that height is the blue one, velocity is the green one, which makes sense. Does that make sense? Okay, so you see how we can use legend to actually plot many charts at the same time? Alright, so when we get to the wind turbine design project, you're going to have to put like 16 of those over each other. So that's why you have to understand how to layer them over each other. Okay. Now, another thing that you can use is if you don't want to plot something in a straight line. Do you see how everything was plotted in a straight line? Let's say you actually want to use dots or circles or whatever it is. Where it says plot t comma height, you can actually use comma. And the third option, you can use O, for example. And if you use O and you go ahead and run this, you'll see that instead of a straight line, it will actually use hollow circles. You can use asterisks over here, and if you run that, that will give you this. You can type G, for example, and that will give you a green curve. Okay, so you can do all these different things, okay, in order to change the way a graph looks. And if you're probably wondering how do you even memorize these things, or how do you know, all you have to do is just type help space plot, okay, and you get a list of all of them here. So if I try to go up here, you'll see that, you know, blue is B, point, circle, all that stuff over here. Okay, so you don't have to memorize it, but you do it enough times that it ends up getting stuck to your head.
What was the command for that?
A help plot. Okay, are we good? Now in some situations, the help over here is not good enough, because let's say you don't really know what the command is. Like help something, you're trying to find a help on a specific command. But if I try to type like help cosine, it's going to give me cosine is not found. Because similar to Excel that we learned last semester, if I type help cos, then that will give me more details, because really cos is the function. Now what happens if I really don't know what that function is? All you have to do, you just come here where it says help, okay, and you can go to either function browser or product help, and this will open up over here, and then I can basically type, the magnifying glass is killing this, but if I type cosine, I will see here that says cosine. Oh, cosine is cos, and I can get examples of how it's actually used, and I can have all these different possibilities over here with additional examples. Okay, so if you don't know the exact function for it, go ahead and use the help menu. Are we clear? Alright, so let's go ahead and erase this, and I'm going to switch gears to dealing with complex numbers. So all of you by this point should know complex numbers. Yes? Where is the flash drive? Where is the flash drive? Okay. Do not lose it. Alright, complex numbers. Do you guys remember what complex numbers are? No? Who doesn't remember what a complex number is? Okay, great. For you, I have prepared a very nice lecture. Okay, so I want you to go ahead and review that on your own time. But I'm going to give you the basic review of complex numbers, which are basically numbers that have an imaginary component in them. So it's A plus IB, where A is the real number, B is also a real number, but IB as a component is the imaginary component. Now what is this ideal? If you guys remember, if you ever have a negative number under square root. For example, the square root of -4 is what? Plus or minus 2i. Okay? So if you have a negative number inside of the square root of -1 is I. That's where I is coming from. Okay? So we can also do complex number operations in MATLAB, and we're going to do a simple example on that, and we're going to move on after that. So let's start with the first complex number, z equals 1 plus 3i. So by simply typing 1 plus 3i, MATLAB will automatically understand that we're dealing with complex numbers. I'm going to go ahead and put a semicolon here. I'm going to say d equals -3 minus 5i. I'm going to put a semicolon there. And I'm going to try to solve for r, which is z multiplied by d. So I'm trying to multiply complex numbers. And please remember that I multiplied by I is I squared, which is -1. Okay, so if I go ahead and solve that, I'm going to get r is 12 minus 14i. And I can do the same thing with division, addition, and subtraction. Okay? Are we clear? Any questions? Okay, so to make sure that everyone's on the same page, I want to give you a quick review of, all of you should know Excel by now. So I'm going to give you just a quick review of the functions that you can use in MATLAB. And those functions, for example, if you want to use an exponential function, it's exp. So it's pretty much just like Excel. If you want to use a square root, it's sqrt. If you want to use ln, it's log. Okay, log base 10 is log 10. Cosine is cos, sine, sine, tangent, and so on. So this is kind of a guide for you in how to use these different functions. Sorry, what? You can do that, yes. We'll get to that. Yeah. It's not that tricky actually, but you just have to change the basis of the operations. And I'll show you one thing today. Okay? Alright, so this is kind of the first thing. Now, if you go back to MATLAB, I want you to try something real quick here. In the command window, go ahead and type 1 divided by 3. Okay, so if you type 1 divided by 3, what happens? You get 0.333. Okay, so you get 4 3s. Now this is known as format short. Format short only shows 4 significant digits or 4 decimal places from your number. So in reality, this is 0.333333. It just keeps going on, right? So if I want to see more details, if I want to see more numbers, by showing 0.33, it doesn't mean that's the number that's actually stored in the background. It's just a display number. But if you guys want to see more digits, all you have to do is you type format space and you type long after it. So format long. And you hit enter. I need to get rid of what? Oh, sorry. Magnifying. There you go. So format long. Okay, and so now if I go ahead and type 1 divided by 3, you'll see that I get a lot more digits for that. Okay, so if I want to take it back to the shorter display, because that's really what we're going to stick with for your assignments, because we don't want to be able to see all these numbers, although they're calculated in the background. You want to take it back, you type format short, and that will take it back to the shorter format. Any questions on this? Okay, so let's go ahead and take a look at your first at a couple of your assignments. So activity 1, it's very simple. I specify the value of x, I specify the value of y, and you just have to do some simple operations. So these are the values. So you have to specify x and y, and these are the variables that I'm actually calculating for. So please use those variables when you're trying to solve your homework. Okay, so don't come up with your own variables or anything like that. Over here, again, it's the same operation, x equals 2, y equals 5. But you'll notice here now we start getting into a bit more complicated divisions and power functions. So please use the proper parentheses and all that to get the correct answer. Okay, so you want to make sure that you're doing the right order of operation. We come over here and we have some simple complex numbers. Okay? Alright, so now we get here. So I know how much you guys love chemistry. Okay, especially the chemists here in the room. So here's your chance to showcase your skills. So here's a problem. Now what I want you to understand from this problem is there are two variables that I don't give you the value for. Okay, so if you notice here, if you just read the details of this problem, you'll notice that these two variables are actually independent of the problem that we're trying to solve, and hence could be cancelled because we're trying to compare situation A to situation B, but we're saying that those variables are the same in both situations. So try to form a ratio, and you'll see that those variables could be cancelled out. Okay? Alright, activity 1.5, we have an X array that's going from 1 to 5, and you notice that we have an increment. So we learned how to create an increment from 1 to 5, and we can create that increment of 0.2, so you can create that array. And I want you to go ahead and develop the Y array, and that you want to tell me how many elements are in that array, and what is the third element. So we showed you also how to do that. So how many elements do we have, and how do we call on a specific element? Okay, any questions on that? Alright, activity 1.6. This is a simple subtraction problem, so I'm going to let you figure that one out. It's very simple to do, not that big of a deal. Now the one I want to focus on is over here. Okay, so this is a polynomial. What I'm asking you to do is find the roots. Okay, now in order to find the roots of this, there's a very simple thing that you have to do, which is basically go to your slides, and alright, we already went through all these examples, nothing is fancy here. I lost it. There it is. Exact same problem, just different coefficients. So go through this example and you'll figure out how to actually do this problem. Okay? It's a very simple code. Alright. For this, remember for ln, what do you use? Log. For e, for what do you use? exp, okay? And for a pi in MATLAB, it's just like Excel, you actually use pi. Okay? So the letters p and I. Is that clear? Okay, now over here, what a lot of you would do is I tell you t is from 1 to 3. So you'll go ahead and you type 1:3. Now that will only create 3 data points. It will create 1, 2, and 3, because MATLAB will automatically assume the increment is 1. What you want to do here is you want to pick a small increment, such as 0.1, 0.01. It doesn't matter, just pick something small because you're not doing it by hand. Otherwise, your chart, it's going to be very sharp changes, instead of having a very nicely smooth change. Okay, so I'm leaving it open for you here to actually pick your own increment. But 0.1 would actually work. Just don't just type 1, 3, because that will cause a problem. You'll have only 3 points, so it'll just look like straight lines being connected to each other. Okay? Now, the last one. Over here I tell you, go ahead and use MATLAB in order to find the meaning of the following. Plot, label, cos, cosine, colon, and the multiplication sign. Okay? Now in some situations you can use the help from the command window just like we did in class, or you need to, I showed you the difference between cos and cosine, right? You can find cos in the command window, you cannot find cosine, so you need to go to that MATLAB Help menu. Now what are you actually turning in? What you're turning in is not the printout of the entire MATLAB Help options. Just copy the first 2 sentences, prove to me that you actually looked it up and you know where it's at, and that will satisfy the requirement for that problem. Is that clear? Okay, so how are you turning in these problems? You're going to open up a Word document. So go ahead and do that now. Okay, and you're going to start in the header, so if you double click on the header, you're going to type your name, the class number that you're in, okay, followed by the activity. So this is activity 1. This is the first homework assignment. By the way, the reason they're called activities, not problems, is because I attended this workshop that apparently if we assign a homework assignment to you and we call it a problem, it creates emotional stress on you. So that's why I'm calling it activity now. I'm always cautious about your emotional status. Yeah. Okay? So you have that header over here. Okay, then we're going to go to page layout, columns, and we're going to split it into 2 columns. Okay, and you're going to see why in a second. So, here's how you do it. You type activity 1.1 code. Okay, so you type the code, you go to your MATLAB, you copy the code, everything under that underline. Okay, so I don't want to see all these comments in the beginning, just give me that code here. Let's save some paper. So just give me that code, so you go ahead and you copy it. So Control C, you come here and you paste it. And then you type results, and you go back to your MATLAB, and you go ahead and you copy the results from the command window. Okay, so from the command window, you copy the results, and you paste them over here. What will happen when you copy the results, you'll see that there's a big gap over here. What you want to do is spend some time to backspace this out so you actually have it on the same line. Is that clear? Any questions? So you'll go ahead and you'll fill this up with all your problems, your activities, sorry. Okay, so you fill it up and you'll see that you'll have this one sheet of paper that has 2 columns of the code and results, code and results, code and results. Okay, and I showed you how to copy your figure too. So this is how we're going to be turning in every homework assignment. Is that clear? The same rules that we said before in SOLIDWORKS still applies. Sharing of files in any way or form is strongly prohibited. Are we clear? Any questions?